Hi, Net 1 aspirants, complex numbers, part number 2. In part 1, we have selected humongous questions from KIPS manual, especially, and federal board past papers, especially KIPS. The next 8 questions in part 2, without wasting time, just solve them. 1 plus under root 3 iota can be expressed as, this form is known as rectangular coordinate form or Cartesian coordinates. Rectangular or Cartesian. Then the options are in polar form. In polar form, how to convert from rectangular to polar coordinates? Let's see and find out. First of all, we are interested in the mod of this one, mod of the given complex number. Its modulus is given by 1 square plus root 3 square. It will become 1 plus 3, that's 4, means R is 2. R or mod z is equal to root 2. Sorry, is equal to 2. Only 2. Is equal to only 2. Okay, and then find the angle. After finding R, find the angle. Theta is given by tan inverse or tan arc y over x. That's our x, that's our y. Iota cannot be taken. So our angle is tan inverse of root 3 over 1. Tan inverse of 3 is equal to 60 degrees. 60 degrees or pi upon 3 radian. 60 degrees or pi upon 3 radian. How to write in polar coordinates in polar form? Our polar form is given by r cis theta. We have r2 cis theta is 60 r pi upon 3. 2 cis 60. This 60 can be written as 2 times CIS, means it is the abbreviation of cos theta plus iota sin theta. Iota sin theta. Sorry, there is 60. Let me write 60. 60, 60. That's our answer. That's our answer. Means our final answer is 2 times cos 60 plus iota sin 60. That is the way to convert rectangular coordinates of a complex number into polar coordinates. First of all, find the mod of the given number, that is our magnitude or radius, 1 plus real part square, coefficient of imaginary part square, and theta is given by tan inverse of 1. That is the form, polar form. R is equal to CIS theta, or some writers write or cos theta plus iota sin theta. Plug in the values and so on. And another study to verify from the options. Sin 30, cos 30, you will get this answer. We have cos 60 is equal to 1 over 2. Cos 60 is r 1 over 2 plus iota sin 60 is root 3 over 2. Multiply 2, you will get 1 plus root 3 iota same. That is the possibility to verify from the options or directly generate this thing. I am writing instead of modulus, I am writing z, I am writing z modulus z or rz. It is modulus is given by the distance from origin of a complex number. Magnitude is also known as distance from the origin of the complex number or the given number. Distance, magnitude of a complex number is tantamount to saying that it is the distance from origin of the given complex number. Pass me the duster. Moving towards question number 2, a good question based on triangle inequality. A good question, a wonderful question. Base making, applying the concept, one should have clarity. Otherwise, it is what it is not. Let's see and find out. Okay, we have given Z1, mod of Z1 is equal to 8 and mod of Z2 is 3. We are asked to find max value max value of difference z1 minus z. Applying triangle inequality, if you are familiar, z1 minus z2, this is less than or equal to z1 plus z2, and this is less than individual mods z1 plus z2. This is known as triangle inequality. We are interested in these two. We are interested in these two. Skip this one. So we have z1 minus z2 is less than or equal to mod z1 plus mod z2. z1 minus z2. Given z1 is mod z1 is equal to 8 and this is 3. z1 minus z2 is less than or equal to 11, and we are asked to find max value. Max value. So max value will be 11 in that case. Max value will be 11 in that case. 11 in that case. 11 in that case. Some write us this inequality in that fashion, in the reverse fashion. This is smaller, this is greater than this one, this is greater than this one, smaller, a little bigger, and bigger quantity. Some writers write as z1 plus z2 is greater than or equal to z1 plus z2, and that is greater than the difference of the z1 and z2. Either write in that way, either write in that way, it's up to you, it's up to you. Both are correct. Like A is less than B, one can write B is greater than A. They are tantamount to each other, they are equivalent. Simply z1 minus z2 is less than this one, sum of the z1, z2, and the modulus of the individual one is greater than this one. We are asked to find max value. It's equal to 8, it's equal to 3, less than or equal to 11, less than or equal to, less than or equal to. We are asked to find max value. Max value will be 11. Will be 11 in that case. Will be 11 in that case. Moving towards question number next. 11 in lump sum. 3 of this frame. Lump sum 11 questions. The selected ones. The good questions. I have tried my best to select some good questions for you. Argument means angle under root 3 plus iota under root 3 minus iota. We are asked to find its argument. For argument, we have formula theta is equal to tan inverse of y over x. Tan inverse of y over x. Here we need a single real part, a single imaginary part. Here we have double. First, simply find this one, rationalize this to get to a single complex number. Then we are in a position to find the angle. Rationalize. We rationalize with the conjugate of the denominator. Conjugate of the denominator. Conjugate means change the symbol of the imaginary part. Change the symbol of imaginary part. According to denominator, change the symbol of the imaginary part. Under root 3 plus iota. Applying whole square formula, we have a square plus twice a into b plus b square, and here difference of two squares under root 3 square minus iota square. Iota square, don't forget to plug in. Iota square is equal to minus 1. So we have 3 plus 2 times root 3 iota. Value of iota square is minus 1. 3 minus a value of iota square is minus 1. If we are doing correct rationalization, then iota will be no more in denominator. Iota will be no more in denominator if we are correct. That is the situation here. 3 plus 2 times root 3 iota minus 1 minus plus. Now subtract real from real. 3 minus 1 it's 2 plus 2 under root 3 iota. We have 4. Separate the real and imaginary parts. Dividing separate with 4. We have 2 times root 3 iota over 4. So we are going to get 1 over 2 plus under root 3 over 2. Now we have a single complex number. Its value of x, its value of y. Now we are in a position to find angle in that case, argument in that case. Theta tan inverse y means the coefficient of imaginary part, that is under root 3 over 2 divided by 1 over 2. Let me write in good fashion. Tan inverse of under root 3 over 2 Make this reciprocal. 2 upon 1 cancelled out. Theta is equal to tan inverse of root 3. Tan inverse of root 3 means 8 tantamount to 60 degrees or pi upon 3 radians. 60 degrees or pi upon 3 radians. So in that case, in first case 11, in that case 60, and in the first one D is the right option. Okay, moving towards next question, a good one as well. If Z1 over Z2 is purely imaginary, no real part in it, then find the modulus of this. Question number 3. If Z1 divided by Z2 is pure imaginary number, then find the modulus of this one. Under what condition Z1 over Z2 is pure imaginary? When x is equal to y, and they are conjugate of each other, one is x plus y iota, then x, second one is x minus y iota, and x, y both are equal, means x plus x iota, and second one is x minus x iota. That is the required condition when they give us z1 over z2 a pure imaginary number. Let's prove. Suppose x over y1, x y iota divided by, according to conjugate, they are conjugate of each other, x minus y iota. Rationalize. Whenever iota is present in the denominator, rationalize with its conjugate. Conjugate means change the symbol of imaginary part. We have x plus y iota divided by x plus y iota. Whole square formula, x square plus 2xy iota plus y square minus iota square divided by difference of 2 square situation, a minus b, a plus b, that's a square minus b square. Plug in the value of iota square is equal to minus 1. We have x square plus 2xy iota plus y square iota square means minus 1. We have x square minus y square iota square means minus 1. Minus plus minus minus plus, so we have x square plus 2xy iota minus y square divided by x square plus y square. Separating real and imaginary parts, we have x square minus y square plus 2xy iota, dividing separate x square y square with real part as well as imaginary part. Okay, we got here. We want it is given to us if condition it is given to us, if it is a pure imaginary, when it is a pure imaginary, when we have no more this term, when it is going to be 0, compare x square minus y square is equal to 0, then x square is equal to y square. This implies that x is equal to y. X is equal to y is the required condition that I have just mentioned and I have proved. We have tallied as well. If x is equal to y, then it results in pure imaginary number. Let's see and find out. Put x is equal to y or y is equal to x. We have x square minus x square divided by x square plus 2xx iota over x square plus x square. They are 0. It's no more. 0 plus, it will become 2x square iota, it will become 2x square. Cancelled out. We have imaginary part. We have pure imaginary part. In that case. Pure imaginary part. They must be conjugate of each other, and their magnitude of real part is equal to imaginary part. That's the required condition. Now we are asked to find its magnitude. Z1 plus Z2 divided by Z1 minus Z2, its conjugate. We are asked to find its magnitude. Let's see and find its magnitude. So Z1 plus Z2 divided by Z1 minus Z2. What sort of these numbers are? They are, Z1 means x plus y iota, they are conjugate of each other, minus This is x minus y iota divided by, sorry, there's plus, there's minus, x plus y iota minus x minus y iota. They are conjugate of each other. Y iota, it is no more. What we have, x plus x, 2x, and here x plus y iota minus x plus y iota. In that case, y cancel. We have 2x divided by 2y iota, 2 cancel. 2 cancel. Here remains x divided by y iota in the denominator, iota in the denominator, iota in the denominator. Don't you worry about this. We are familiar. 1 upon iota is equal to minus iota. So this one can be written as negative x over y iota. And we have also assumed that x is equal to 1. X is equal to 1. Put x is equal to 1. We are going to get minus x over x iota. Cancelled out. We have negative iota. We have negative iota. Find its magnitude. No real part. 0 square plus minus 1 square. So minus 1 square means 1. Square root of 1 is 1. Square root of 1 is 1. So our magnitude of this quantity z1 plus z2 over z1 minus z2 is 1. Is 1. At least we have given this situation. Z1 divided by Z2 results in pure imaginary. In pure imaginary, we have claimed that they must be conjugate of each other and their magnitudes are equal to the simple condition. The simple condition leading us to the magnitude of this one, where Z1 and Z2 are any complex number, but meeting our two conditions, x is equal to 1. Second, they are conjugate of each other. Then they result in pure imaginary number. Then we are in a position to find its magnitude. Okay. Moving towards the next question. The smallest positive integer k for which 1 plus iota divided by 1 minus iota raised k. Look at this one. We have done this question. Our number must be conjugate of each other. They are conjugate of each other. It also results in conjugate of each other. Conjugate of each other. Conjugate, it is given us, they are conjugate. Just take care of this. This is important point to be noted while dealing with, while negotiating the complex number problems. Find the smallest integer k for which it is equal to 1. Means 1 plus iota, 1 minus iota raised k is equal to 1. Is equal to 1. We are familiar, for complex number we need a single real part, a single imaginary part. Might be real part is altogether missing or imaginary part altogether missing. If present, one real, one imaginary, that is not the situation here. Make it a single complex number by rationalization. 1 plus iota. Rationalize according to the denominator. But the conjugate of 1 minus iota, 1 plus iota. Conjugate means change the symbol of imaginary part. It will become 1 plus iota. 1 plus iota raised k. It is equal to 1 given to us. 1 square formula, 1 square plus twice first into second plus the square of second. In denominator, difference of two square situation. 1 square minus iota square. Don't forget to collectively raise to k. Iota square is equal to minus 1. Plug in the values. 1 plus 2 iota. Value of iota square is minus 1. Over 1 square means 1. Iota square means minus 1. Raised k. Raised k. Raised k. Okay. Then let me write 1 plus 2 iota minus 1 divided by 1 plus 1 overall raised k. Cancelled out. 2 iota 1 plus 1, that's 2 raised k. Cancelled out. It's equal to 1. Means iota raised k is equal to 1. Iota raised k is equal to 1. We are interested in smallest positive integer k that results in 1. We are familiar. Iota power 4 is equal to 1. Iota power 4 is equal to 1. So k is equal to 4 in that case. If one is the curious mind who wants to get to the bottom of this logic, then one can write iota k. 1 can be written as iota raised 4. We can convert 1 into iota. Iota power 4 is equal to 1. Bases are equal, therefore powers are equal. Bases are equal, therefore powers are equal. K is equal to 4 is our answer in that case. Cool. Moving towards the next question. That is, if n is a positive integer means natural number, then the value of iota raised 4 power n plus 1 minus iota raised 4 n minus 1. Let me clarify the situation. Okay, cool. We are asked iota raised 4 n plus 1 minus iota raised 4 n minus 1 divided by 2. If n is any positive integer where n belongs to natural numbers, or one can write positive z. Positive z. Cool. Just utilize the fact iota power 4 is equal to 1. Everybody is familiar. Iota 4 is equal to 1. Okay. By tiny exponent rule, I can write this figure as iota raised 4n times iota raised 1. This one can be written as this. Similarly, the other portion minus iota raised 4 power n times iota raised minus 1 divided by 2. By simply utilizing the tiny exponent rule, x raised m plus n is equal to x raised m times x raised n. Okay, now taking iota power 4 n common, iota power 4 n common, what remains here? Iota, and here iota raised minus 1 divided by 2. Utilize the fact iota 4 is equal to 1 and n is a positive integer. So this one can be written as iota raised 4 raised n. Iota 4 means 1. 1 raised to any natural number power is equal to 1. 1 raised to any natural number power is equal to 1. So it is equal to 1. It is equal to 1. Here iota minus iota raised minus 1 can be written as 1 upon iota divided by 2. Divided by 2. Iota raised minus 1 can be written as 1 upon iota, and we are familiar 1 upon iota is equal to minus iota. Instead of this one, we can write minus iota. Iota 1 upon iota is equal to minus iota divided by 2. Minus minus plus iota divided by 2. Iota plus iota, 2 iota divided by 2, or iota is the answer in that case. If n is any positive integer, the value of iota raised 4 n plus 1 minus iota raised 4 n minus 1 divided by 2, where n is a natural number or positive integer, it's equal to iota. It's equal to iota. Cool. Same fact, utilize 1 over iota is equal to minus iota and find its magnitude. It also works wonderfully. Moving towards next question, that is also based on rationalization and conjugate of each other. Rationalization and conjugate of each other. Okay, we have find the magnitude of 1 plus iota. 1 plus iota. Oh God. 1 plus iota divided by 1 plus 1 upon iota, magnitude of this. Okay, we are familiar. 1 over iota is equal to minus iota. Wonderful. 1 plus iota, it can be written as minus iota. It can be written as minus. Same situation that we have done just in that. Again, rationalize to get to make it a single complex number. Single complex number means single real part, single imaginary part. Rationalize, it will become 1 plus iota, 1 minus iota. Divide and multiply by its conjugate, 1 plus iota divided by 1 plus iota. Whole square formula, a square plus twice a into b plus b square. That is a minus b plus b. It's equal to a square minus b square. Iota square is equal to minus 1. Iota square is equal to minus 1. Here also iota square is equal to minus 1. Minus plus minus 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 plus. It will become 1 plus 2 iota minus 1 divided by 1 plus 1. No more. We have 2 iota divided by 2 cancelled out. We have only iota. Finding its magnitude, no real part 0. Coefficient of iota is 1, 1 square. 1 square means square root of 1 is 1. So magnitude of this is also 1. Magnitude of this is also 1. Moving towards last question. That is also based upon iota's exponent. Sn is equal to iota power n plus iota. Then the total number of distinct non-zero values of Sn. We have Sn is equal to iota raised n plus iota, where n belongs to integers. N belongs to integers. How many distinct non-zero roots? Non-zero values of this one. Non-zero means we cannot accommodate zero. Non-zero values. Okay, cool. Don't go here and there. Just simply stuck to this one. Iota power n. If you put positive integer or negative integer, you will always get these values for any power of iota 1, minus 1, iota and minus iota. One can easily prove whatever the power of n, where n belongs to z, when n belongs to z integers, you will get 1 minus 1 iota minus iota. Let's see and find out. Suppose iota power 1, it's iota. Simply iota square minus 1, iota cube minus iota, iota 4 is equal to 1. Keep on increasing the power. Iota 5, iota 5 can be written as iota power 4 times iota, iota power 4 1 times iota, that's again iota. The loop repeats, iota power 6, iota power 6 means iota 4 times iota square, iota 4 means 1, iota square means minus 1, it will become minus 1, here minus 1, iota power 7, one can write iota power 4 times iota cube, iota 4 means 1, iota cube means minus iota, it will become minus iota. The values are repeating. So where n belongs to z, I have taken only positive natural numbers. Positive. What about negative? Let's see and find out. They also result in same. 1 minus 1 iota minus iota. Let's see and find out. Iota raised minus 1. Iota raised minus 1 means 1 upon iota. 1 upon iota after rationalization result in minus iota. Okay, cool. Iota square. Iota raised negative 2, it can be written as 1 over iota square. Iota square means minus 1, it will result in minus 1. Look at this. Iota raised minus cube, it can be written as 1 over iota cube. Iota cube, iota cube is equal to minus iota. And minus 1 upon iota is equal to positive iota. Iota raised negative 4, it can be written as 1 upon iota power 4. 1 iota power 4 means 1. 1 upon 1 means 1. Similarly, one can verify iota raised minus 5. We will get 1 upon iota power 5. Iota power 5 can be written as iota power 4 times iota, means iota 4 1 times iota. 1 upon iota means minus iota. So n might be any integer, positive or negative. Even if I put n power 0, we will get 1. So these are the values for all different possibilities of integers. 1, minus 1, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 4. Or value of iota raised n always results from any one of these 4. Okay, now we are in a position to crack this question. How many non-zeros? Values of Sn were non-zero. We cannot accommodate 0. Okay, cool. S1, iota raised 1 plus iota, it will become 2 iota. Cool. S2, iota square plus iota. Iota square means minus 1 and it is plus iota. S2, S3 now. S3 means iota cube plus iota. Iota cube means minus iota plus iota. It is equal to 0. S3. We cannot accommodate this because we are interested in non-zero values. So this is not in our domain. We exclude this one. What about S4? S4 is iota raised 4 plus 1 plus iota. Iota raised 4 plus iota. Iota raised 4 is 1. 1 plus iota is R1 plus iota. Okay, this is it. S5. S5 means iota power 5 plus iota. Iota power 5 means that is only iota. Iota power 5 can be written as iota power 4 times iota plus iota. Iota power 4 is equal to 1. Iota plus iota. So it is 2 iota. It is repeating now. What about S6? Iota raised 6 plus iota. Iota raised 6 can be written as iota 4 times iota square plus iota. Iota power 4 means 1 iota square minus 1. Minus 1 plus iota. Here this possibility also repeats. What about S7? Iota raised 7 plus iota. Iota raised 7 can be written as iota power 4 times iota cube plus iota. Iota power 4 means 1. That is iota cube plus iota. Iota cube means minus iota. Minus iota plus iota cancel 0. We cannot this possibility. Take the different possibilities. Number 1, we can take number 2. It is deleted. Number 3, different possibilities. 2 iota. What are the different possibilities? Let me write here. 2 iota. That is minus 1 plus iota. Here 1 plus iota. Then same 2 iota repeats, minus 1 plus iota. These are the 3 non-zero possibilities. These are the 3 non-zero possibilities for n belongs to z. N belongs to z. Whether n is a natural number, positive integer or negative integer. I have explained you in detail. Iota power n results in 1 minus 1 iota minus iota, minus iota when n belongs to integers. N belongs to integers. I have proved as well. This is the loop. Whenever our answer is minus iota plus iota, it will become 0. And we are forbidden, we are interested in non-zero values. That's why we are excluding this possibility. That's why we are excluding this possibility. The remaining possibilities are 3. We have proved, we have dealt in detail. It's my tiny effort for you, complex number. Part 3 also coming for you, 8 questions in a single frame or enough for you to digest. It's all by itself. Next.